Hey everyone, and welcome back for another deep dive.
Glad to be back.
Today, we're going to be digging into some seriously cool stuff coming out of China's space program.
It's amazing what they've been accomplishing.
I know, right? They've been kind of quietly racking up these huge E-wins out there in space, and honestly, it's time we all caught up on what they're learning.
Absolutely.
Especially about, the moon and Mars.
Yeah, they're giving us some totally fresh perspectives on those places.
And they're coming up with some crazy findings, too.
Oh, yeah.
I mean, it's like straight out of science fiction, some of this stuff.
Definitely.
So we've got 3 missions we're going to focus on today.
Okay.
Chang'e 4, Chang'e 5, and Tianwen 1.
Quite a lineup.
I know, right? From landing on the far side of the moon to uncovering evidence of Mars's ancient past. I mean, come on, how cool is that?
So cool.
Okay, so let's start with Chang'e 4.
Okay.
This was the first spacecraft ever to land on the far side of the moon.
A major achievement.
Right. And that far side, it's always hidden from us here on Earth, so I can only imagine that made things super tricky for the mission, right?
Absolutely. It was a huge challenge.
I bet.
I mean, imagine trying to control a rover when you can't see it or talk to it directly.
Yeah, that's going to be tough.
So to overcome this, China actually launched a special relay satellite.
Oh, interesting.
Yeah, it basically acts as a middleman,
Okay.
bouncing signals between the lander on the moon and back here on Earth.
So that's how they did it.
Yep.
Clever. It's like having, a walkie-talkie in space.
Exactly.
So where exactly on this, mysterious far side did Chang'e 4 touch down?
It landed in the Von Karman crater,
Okay.
which is tucked inside this giant basin called the South Pole Aitken Basin.
Wow, a basin within a basin.
Yeah, and scientists think that this whole area is billions of years old,
Oh, wow.
a true relic from the moon's early history.
Talk about a time capsule, right? So, what did Chang'e 4 and its rover, U-22, actually find when they got there? I'm, especially curious about that lunar regolith.
Oh, yeah.
You know, that powdery stuff that covers the surface?
Yes. Well, they discovered that the regolith on the far side is made up of these incredibly fine grains, way smaller than the width of a human hair.
Wow, yeah.
And it's piled up in these layers, kind of like a lunar layer cake.
A layer cake, huh?
I know, right? And each of those layers was formed by billions of years of meteoroid impacts.
So each layer is basically a record of cosmic bombardment.
Exactly. It's incredible, right?
It really is. Okay, so I remember reading something about Chang'e 4, finding something surprising about the regolith, too, something about how well it insulates.
Yes. So it turns out that this lunar regolith is a fantastic insulator. It can keep things warm or cool, depending on what you need.
Really?
Yeah. And this discovery has engineers thinking about using it as insulation for future lunar bases.
Oh, wow, that's so cool.
Imagine building habitats partially buried in the lunar soil, shielded from those crazy temperature swings on the moon.
That's pretty amazing. Talk about living off the land.
Right.
That would be a game changer.
It really would.
I've heard, though, that the far side of the moon is also a bit of a radiation hotspot.
Yeah.
Not exactly the best place to build a house, right?
True.
Did Chang'e 4 tell us anything about that?
It sure did.
Okay.
It actually confirmed that the far side gets blasted by way higher levels of radiation compared to the near side.
Really?
Yeah, this is because the far side is more exposed to the solar wind.
So it's like the near side of the moon is behind a shield, and the far side takes the full force.
Exactly.
So how did they even measure this radiation on Chang'e 4?
So they equipped the U-22 rover with 2 special instruments, ASAN and LND.
Okay, what do those do?
So ASAN analyzes those low-energy particles that are produced when the solar wind slams into the moon's surface. It's kind of like studying the aftermath of a microscopic meteor shower.
I like that analogy.
And then LND, that focuses on the overall radiation levels and the impact of cosmic rays.
So they're getting a really detailed picture of what that radiation environment is like on the far side.
Exactly.
Did those instruments find anything particularly surprising?
One of the most intriguing findings was the detection of what we call mini magnetospheres.
Mini magnetospheres.
Yeah, basically ASAN found these partially formed magnetic fields around certain spots on the moon.
Like little force fields.
Exactly. They're like small, localized bubbles of protection.
Do you think these mini magnetospheres could actually help protect against that radiation?
That's a question scientists are trying to answer right now.
Okay.
It's still early, but the potential is there.
That's so cool. It's like these missions are not only showing us the moon's past, but they're shaping our future in space, too.
I know, right?
So cool. It sounds like Chang'e 4 has given us a ton to think about when it comes to lunar exploration. Now let's switch gears and talk about Chang'e 5, which had a completely different mission, bringing pieces of the moon back home.
Yes. In 2020, it successfully brought samples of lunar soil back to Earth.
Wow,
It was the first mission to do so since the 1970s.
that's amazing.
And these samples are giving us a direct look at the moon's composition and its history.
It's like having a piece of the moon delivered right to our doorstep.
Exactly.
I'm dying to know what makes the Chang'e 5 sample so special.
Well, for starters, the composition of the soil is unlike anything we've analyzed before.
Okay.
It's got a higher concentration of iron oxide, which gives the moon that kind of rusty hue, along with some moderate amounts of titanium dioxide and aluminum oxide.
So it's not just any old moon dust, huh?
Not at all. And the analysis suggests that a lot of this soil came from the Shugwanki crater,
Okay.
a site that's been hit by countless micrometeoroids over the years.
Micrometeoroids.
Yeah, those tiny space rocks that are constantly pelting the lunar surface.
Wow, it makes you wonder why we even bother cleaning our houses here.
Right.
So these micrometeoroids are like little sculptors constantly reshaping the moon.
Exactly. They play a huge role in creating that fine, powdery soil we see.
It's a never-ending process.
It really is.
Speaking of transformations, I've got to ask about these impact classes found in the Chang'e 5 samples.
Yes.
What are those exactly? They sound like something straight out of a sci-fi movie.
They do, don't they?
Yeah.
So impact glasses are formed by the insane heat and pressure of meteoroid impacts.
Okay.
When a meteoroid slams into the moon, it basically melts the rock around it.
Oh, wow.
And then that molten material cools super fast and solidifies, forming glass.
So it's like the moon is making its own stained glass windows.
I love that analogy. And what's really fascinating is that these impact glasses come in all sorts of shapes and sizes.
Really?
Yeah, some of these long, thin fibers. Others form these thin, amorphous layers.
And each one tells a story about the impact that created it.
Exactly.
That's incredible. I bet we can learn a lot about the moon's history from studying these glasses.
We can. By analyzing their composition and age, we can actually reconstruct a timeline of the impacts on the lunar surface.
It's like piecing together a giant cosmic puzzle,
It really is.
revealing all the events that have shaped the moon over billions of years.
Precisely.
Mm-hmm.
And what's really cool is that the composition of some of these glasses suggests they formed relatively recently, geologically speaking at least.
Oh, really? I thought they'd all be from, like, way back when.
Well, some are, but others we're talking maybe a few million to 2 billion years old.
Wow, that's much younger than I expected.
It is, isn't it?
So the moon is still, like, an active place in a way.
Oh, yeah, definitely.
So, like, what else can we actually learn from these impact glasses besides, how old they are?
They can give us clues about how often and how intense these impacts were over time,
Okay.
which helps us understand, like, the bigger picture of how the moon evolved and even our solar system as a whole.
It's crazy how much information we can get from these tiny pieces of glass.
I know, right?
Okay, so I remember reading something about a particular type of impact glass found in the Chang'e 5 samples. Something about creep.
Ah, yes. The creep-rich impact glass.
Yeah, that's it. What is creep, anyway?
So CREEP, it's an acronym. It
Yeah.
stands for potassium, rare earth elements, and phosphorus.
Oh.
And it's this geochemical component that you find in some lunar rocks. And scientists think it's a leftover from when the moon was covered in a magma ocean.
Wait, a magma ocean? You mean like the whole moon was molten rock?
Exactly. Early on in its history, the moon was super hot, like completely molten.
Wow.
And as it cooled down, different minerals started to solidify at different times. And creep, that represents some of the last bits of that magma ocean to solidify.
So finding creep-rich impact glass is kind of like finding a message in a bottle from the moon's early days.
That's a great way to put it.
That's wild.
It really gives us a glimpse into a time when the moon was a totally different place.
Okay, so we've talked about the ancient past, but what about all those impacts that are still happening today? Like the micrometeoroids and the solar wind, how are those affecting the moon's surface?
That's a great question. We call that process space weathering.
Space weathering.
Yeah, and it's constantly changing the lunar surface. Like, imagine a sculptor
Okay.
meticulously chiseling away at a statue. But in this case, the sculptor is the solar wind and those tiny micrometeoroids, and the statue is the lunar surface.
So it's like a constant sandblasting from space.
Yeah, pretty much.
Wild.
The Chang'e 5 samples have actually given us some fascinating insights into this space weathering process.
Oh, really? Like what?
Well, for example, they found that iron-rich basalts, which are common on the lunar surface,
Okay.
they undergo this rapid transformation where these tiny particles of metallic iron, called NP0, form and clump together.
Huh, so the iron is changing because of space weathering.
Exactly. They also saw NP-FeTO forming on the surface of olivine,
Which is
another mineral that's common on the moon. And this tells us that space weathering affects different materials in different ways.
That's so cool. It's amazing how these missions are showing us all these subtle but powerful forces that are shaping the moon over time.
It really is.
Okay, but there's one discovery from Change of 5 that really caught everyone's attention. Water.
Ah, yes, the water discovery.
It was huge news, right?
It was. But it's important to remember that we're not talking about, like, rivers and lakes.
Right, right.
This water is different.
Okay.
It comes from the solar wind.
Solar wind water. How does that work? I always thought the solar wind was just a bunch of charged particles.
It is, mostly.
Okay.
But one of those particles is hydrogen.
Okay.
And when these hydrogen ions hit the moon's surface, they react with the oxygen that's already there in the soil.
And that creates water.
Exactly.
That's amazing. But if the solar wind is constantly bringing water to the moon, how is it being stored? Wouldn't it just, like, evaporate out into space?
That's where those impact glasses we talked about come in.
Oh, right.
They actually act like little water traps.
Really?
Yeah, they capture those water molecules and prevent them from escaping into space.
So those impact glasses are like tiny reservoirs.
You got it.
That's incredible. How much water are we talking about here?
The Chang'e 5 samples show that some of these impact glasses can hold up to 2,000 parts per million of water.
Wow, that's a lot. So there's actually quite a bit of water on the moon, even if it's not in a liquid form.
Exactly. It suggests that the moon might have a more active water cycle than we realized.
A lunar water cycle. So, like, water is constantly moving around and changing forms on the moon.
That's the idea.
Yeah.
It's a really exciting discovery because this water could be a valuable resource for future missions, for things like life support or even rocket fuel.
That's amazing. Imagine one day we might be mining water on the moon.
It's a real possibility.
Okay, before we move on to Mars, there's one more thing from Chang'e 5 that I want to touch on. The basalts.
Ah, yes, the basalts.
What can those tell us?
So basalts, they're volcanic rocks. And they give us a peek into the moon's volcanic past. Remember that magma ocean we talked about?
Yeah.
Well, the basalts show us that volcanic activity continued long after that magma ocean cooled down.
So the moon wasn't always cold and dead.
Nope. It was a pretty fiery place for quite a while.
I love it. What did the Chang'e 5 basalts tell us about this volcanism?
Well, they suggest that lunar volcanoes might have been erupting for much longer than we thought.
Really? Like how much longer?
Potentially up to 2 billion years ago.
Yeah.
And maybe even as recently as 120 million years ago.
Wow, that's a lot more recent than I would guessed. So the moon was active for way longer than we thought.
It seems that way.
It's amazing how Chang'e 5 has totally changed our understanding of the moon.
I know, right?
It's not just this, like, static, ancient world. It's dynamic, it's complex, and it's got a lot more going on than we ever imagined.
It really does.
Okay, so now let's shift our focus to another celestial neighbor that's always captured our imaginations. Mars. And specifically, China's Tianwen-1 mission, with its rover, Zhurong, exploring the Utopia Planitia region.
Such a cool mission.
I know, right? And it's been making some really exciting discoveries, unveiling all sorts of secrets about Mars's past and present.
Absolutely.
So Tianwen-1, it's not just a rover, right? It's like a triple threat.
It is. We've got an orbiter circling Mars.
Okay.
We've got a lander that touched down safely. And then, of course, we've got the Zhurong rover trundling across the surface, gathering all that valuable data.
A triple threat indeed. So let's start with the Martian landscape. What's Zhurong been seeing as it explores Utopia Planitia?
One of the most striking things Zhurong has encountered are these wind-sculpted landforms.
Wind-sculpted?
Yeah. We call them aeolian landforms.
Aeolian landforms.
They include things like transverse aeolian ridges, or TARS for short, and dunes, all shaped by the Martian winds.
Wait, Mars has wind?
Oh, yeah, definitely. And it's been a major force in shaping the planet's surface over millions of years.
That's crazy. It's not just Earth that has wind shaping its landscapes.
Not at all.
So what can these aeolian landforms tell us about Mars?
They're like time capsules.
Okay.
They hold a record of Mars's climate history. And by studying their shapes and how they're oriented, scientists have actually found evidence of major climate shifts on Mars.
Really? Like what?
Well, specifically, they found signs of a transition from a time when ice covered large parts of Mars, a glacial period,
Mars had ice ages.
It did.
Wow.
And then it transitioned to a warmer period, an interglacial period, which is what we see today.
So, like, Mars has gone through cycles of ice ages and warmer periods, just like Earth.
Exactly.
That's incredible. And these climate shifts, they actually changed the wind patterns on Mars.
They did.
Wow.
And those changes in wind direction, those are what reshaped the surface and created those distinct landforms as Zhurong is seeing today.
It's amazing how these subtle features on the surface can tell us so much about Mars's past.
I know, it's like reading a history book written in sand and rock.
But Zhurong's not just looking at the surface, right? What about what's going on beneath the surface?
You're right. Zhurong has this ground-penetrating radar
Okay.
that allows it to see what's hidden underground.
Cool. And what's it found down there?
Well, it's found evidence of multiple resurfacing events in Mars's past.
Resurfacing events.
Yeah, like times when the surface was completely transformed, probably by things like massive floods or volcanic eruptions.
Oh, wow. So Mars has a hidden history buried beneath its surface.
Exactly. And these resurfacing events, they've left behind these layers of rock and sediment,
Mm-hmm.
kind of like a geological layer cake.
I like that analogy.
And what's really exciting is that these layers suggest that water might have played a much bigger role in Mars's past than we thought.
So more evidence pointing towards a watery past for Mars. I'm sensing a theme here.
There's definitely a lot of evidence pointing in that direction.
Is there anything else that supports this idea that Mars was once a wetter place?
Absolutely. Zhurong has also found water-bearing minerals on the Martian surface.
Water-bearing minerals.
Yeah, things like polyhydric sulfates and gypsum. These minerals can only form in the presence of water.
So they're like a smoking gun.
Pretty much. They're telling us that liquid water was definitely present on Mars at some point.
It's incredible to think about, like, Mars maybe having lakes, rivers, or even oceans billions of years ago.
I know, right?
But if Mars was so wet, where did all that water go?
That's a great question, and one that scientists are still trying to answer.
Okay.
We think a lot of it probably escaped into space as Mars's atmosphere got thinner, but some of it might still be trapped beneath the surface.
Like in those subsurface glaciers you mentioned earlier?
Exactly. There could be huge reservoirs of ice hidden under the Martian soil.
That's so cool. Those subsurface glaciers, they could be a lifesaver for future human missions, right?
Absolutely. Water is essential for life support, and it could even be used to make rocket fuel.
So we could, like, refuel our spacecraft on Mars using water from these glaciers.
That's the idea. It would make traveling to and from Mars a lot easier.
Okay, so we've talked about the ancient past, but what about Mars today? What's Zhurong been telling us about what it's like to actually be on Mars right now?
Zhurong has been busy collecting data on all sorts of environmental factors, like how much dust is deposited, how the wind is blowing, and what the surface temperatures are like.
That's a lot of data. What about that Martian dust I've always heard about? It sounds like it can be a real problem for missions.
Oh, it definitely can be.
What's Zhurong found out about it?
Well, Zhurong's observations have shown that during the Martian spring and summer, strong winds whip up this dust into these huge dust storms.
Dust storms on Mars?
Yeah, and they can sometimes cover the entire planet.
A planet-wide dust storm? That sounds terrifying.
They're pretty intense.
I bet.
And they can really mess with the Martian climate.
Mm.
They change the temperatures and how the atmosphere circulates.
Wow. I'm starting to see why Martian weather is so challenging for missions.
It's definitely something we have to take seriously.
What about the temperature on Mars in general? How cold does it actually get?
Zhurong has a Mars climate station that's been taking the planet's temperature.
Okay.
And it's found that temperatures can swing wildly depending on the time of day and what season it is.
So, big temperature swings, huh?
Yeah, and things like dust and something called thermal inertia play a big role in these swings.
Thermal inertia.
Yeah, it's a measure of how quickly a material heats up or cools down.
Mm.
So, for example, a rock takes a long time to warm up in the sun, but it also takes a long time to cool down at night.
Okay.
Whereas sand heats up and cools down much faster.
Makes sense.
And since Mars has such a thin atmosphere, it doesn't hold heat very well.
Hmm.
So these differences in thermal inertia can create big temperature differences across the surface.
So depending on where you are and what you're standing on, the temperature could be drastically different.
Exactly.
Okay, now for the question that's on everyone's mind. Liquid water on Mars today?
Ah, yes, the big question.
Is there any chance of finding it?
Well, because the air pressure on Mars is so low and the temperatures are so cold, liquid water isn't very stable on the surface. But there is some evidence that we might find briny water just below the surface.
Briny water? What's that?
It's water that has a lot of salt in it.
Okay.
And the salt acts like antifreeze, so it lowers the freezing point of the water.
So even though it's super cold on Mars, briny water could stay liquid underground?
Exactly.
That's pretty cool. So there could be these pockets of liquid water, even if it's super salty, hiding beneath the surface.
That's what the evidence suggests. And these briny aquifers could be incredibly useful for future human missions.
Yeah, talk about a valuable resource. What else has Zhurong found out about the possibility of water on Mars?
So Zhurong's Mars Climate Station has been watching frost form and then sublimate, which means the ice changes directly into water vapor.
Okay.
And this tells us that Mars still has active water vapor cycles.
So even though there might not be rivers and lakes, water is still playing a role in the Martian environment.
Exactly.
Okay, so Zhurong has been busy, but what about the Tianwen-1 orbiter? What's it been up to?
The orbiter has been giving us a broader view of things.
Okay.
It's been studying the Martian space environment and how it interacts with the solar wind.
The solar wind, that's that stream of charged particles from the sun, right?
Yep, that's it.
I've always been curious about the solar wind. How does it affect Mars?
The solar wind can have a big impact on planets, especially ones that don't have a strong magnetic field, like Mars. The orbiter's observations have shown us just how important the solar wind is in shaping the space environment around Mars.
Okay.
It's also given us some insights into something called cross-field diffusion.
Cross-field diffusion.
Yeah, it's a bit complicated, but it's basically how charged particles move across magnetic field lines. It plays a big role in how the solar wind interacts with planets.
Okay, so the orbiter is helping us understand how Mars is connected to the sun and how the solar wind is constantly shaping the Martian environment.
Exactly. And it's also been gathering data on the Martian bow shock.
The Martian bow shock, what is that?
It's the region where the solar wind slams into Mars's magnetic field. It's like a cosmic traffic jam where all these charged particles are colliding and getting deflected.
Sounds chaotic.
It is. But it's also super important for understanding how Mars interacts with the solar wind.
So the orbiter is giving us a front row seat to all this cosmic action.
It is. It's providing us with a much more complete picture of Mars, from its surface to its atmosphere to its magnetic field.
It's incredible how much we're learning from these missions. Chang'e 4 and Chang'e 5 have completely changed how we think about the moon.
I know, right?
And Tianwen-1 is doing the same for Mars.
Absolutely.
It's an exciting time for space exploration. It's amazing how much we're learning, right?
It really is. It's like we've gone from these blurry pictures and theories to like high definition data and actual proof.
It feels like we're finally starting to get a real handle on these places.
I agree.
And it's not just about the knowledge itself, but what we can actually do with it. Like, think about that water on the moon. That has huge GE implications for lunar missions.
Absolutely.
We're not just talking about short trips anymore.
Yeah.
We're talking about, like, a permanent human presence up there.
It's an exciting prospect.
So cool. And imagine, like, lunar bases becoming a reality.
Yeah.
Using the moon's resources to build habitats and generate energy, maybe even make rocket fuel.
It's starting to feel more and more achievable.
I know, it's crazy. And then there's Mars. With all this evidence of past water and those potential glaciers underground, it feels like we're edging closer to answering that big question.
Yeah.
Was there ever life on Mars?
That question has been driving us for so long.
I know, right?
And all this new evidence we're gathering is like incredibly tantalizing.
It really is. Imagine if we actually found evidence of life beyond Earth.
It would be huge, E.
Right. I mean, it would change everything.
It would redefine our place in the universe.
Exactly. We wouldn't be alone anymore.
We'd be part of something much bigger.
Part of a cosmic community.
I love that, a cosmic community.
And to think, we might be living in the time when that discovery happened.
It's incredible, isn't it?
It really is. It's a pretty amazing time to be following space exploration.
The best time.
And with China's space program going full steam ahead.
I know, right?
Who knows what other groundbreaking discoveries are just around the corner.
I can't wait to find out. Their ambition is truly inspiring.
Absolutely. Well, as we wrap up this deep dive into China's space program, I want to leave you with a thought. What are you most excited about when you think about space? What mysteries do you hope will solve? What new worlds do you want to explore? Keep those questions in mind the next time you look up at the night sky, because those answers might be closer than we think. Thanks for joining us, and keep looking up.